Hi everybody, this is Julian from Hugging Face. Retrieval-Augmented Generation, also known as RAG, is a popular technique to build more efficient chatbots. In this video, I'm going to show you how to build a RAG chatbot using a combination of open source libraries and AWS services. So we'll use LangChain, Hugging Face, the Face library from Facebook, Amazon SageMaker, and Amazon TextTrack. Okay, so quite a lot of toys to play with. Let's get to work. Before we jump into the code, let's take a look at the typical chatbot architectures. The simplest one is really this one, where we start from a user query, wrap it in a system prompt, send the query to a large language model, and generate an answer. Okay, and this is the good way to start. There's nothing wrong with this. There are limitations, however. Obviously, knowledge only comes from the initial training process, which means that recent events are not taken into account, the so-called cutoff date problem. Domain and company knowledge could be too shallow because obviously the LLM wasn't trained on your internal company data. So there could be a problem there. Maybe if you ask deep domain questions, you're going to get shallow answers. And if you take the model out of domain, if you ask deep domain questions and the LLM never really saw that kind of data during the training process, it's likely that the model will hallucinate. Obviously, you could fine-tune the LLM on your internal data to mitigate those problems, but how often are you willing to run it? If you need very fresh answers, if you need to know what happened yesterday, obviously fine-tuning is not a great option because you don't want to fine-tune again and again and again every single day, right? So this is where Retrieval-Augmented Generation steps in, and we really look at two different workflows here. So the first workflow is really an ingestion workflow where we start from internal documents, which could be text or images or anything really, and we embed them using an embedding model. Which really means we turn those documents or document chunks into high-dimensional vectors, which we store in some kind of database that will let us query, right? And now the workflow looks something like this. We start from the user query, we embed the query itself, we run vector proximity search or semantic search against our embeddings database, and we return the top 5, top 10 documents that are closely related to the query. And we wrap everything in a system prompt, which goes something like, hey, has a helpful assistant, please answer the following query, blah, 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 using context found in those documents, right? And then we generate the answer. And the two benefits here are obviously if we have fresh knowledge, right? Because the ingestion process could be running constantly in real time. If we have fresh knowledge, and as soon as that knowledge is embedded and available in the database, then it can be discovered and it can be added to the generation process. And the second benefit is if we trust our search mechanism to work, then we're always bringing relevant context to the generation, meaning that if the query is taking the vanilla LLM out of domain, at least we're pointing it to relevant information to start generating a good answer instead of letting it, hallucinate and invent stupid things. So that's what RAG is all about, and that's pretty much what we're going to build. Okay, so let's switch to the notebook and let's start running some code. So what are we building here? In a nutshell, we're going to build a chatbot that can retrieve information extracted from PDF files. Okay, so we'll start from a few PDF files containing information about energy trends and the energy market. Right? Why not? Domain-specific documents. And we're going to process those documents, embed them, store the embeddings in a Face database, and Face is a really nice library from Facebook. We'll talk about that later. And then we're going to deploy an LLM on SageMaker, and we're going to query that LLM using hopefully relevant context extracted from our embeddings. Okay, so this is what we're going to do. So let's get started, right? Let me zoom in maybe a bit. Okay, so obviously first we need to install some dependencies, the SageMaker SDK, LangChain to orchestrate everything, and a couple of additional packages for Amazon Text Extract and PDF processing. Okay, we need to import all those objects. We'll obviously see them again. Okay, the first step is to deploy our LLM, okay, on a SageMaker endpoint. So as you can see here, I am deploying the Mistral 7B model, and this is a particular variant fine-tuned for instruction following. So it's this particular model here. Okay, again, all the links will be in the video description. Okay, so 7 billion parameter model. Not a lot to worry about. We just need to keep an eye on the prompting format. Okay, but we'll get back to that. So deploying this model is super simple. In fact, I didn't write any of this code. I just decided to go here, click on deploy, SageMaker, and copy paste that code here, right? And that's all I did. So that's one of the reasons why, you know, using SageMaker is a simple option, because you can just copy paste and deploy, right? So we run this. There's really nothing to explain, I guess, right? Pointing at the model on the hub, using the built-in container for LLM inference on SageMaker, deploying on a small G5 instance. This one has a single A10G GPU, so pretty small, not expensive, probably just about $1 an hour. So not an expensive instance by any means. Okay, we wait for a few minutes, and then we have our endpoint. Okay, and we just need to grab the endpoint name, because LangChain is going to need that. Okay, so now we have our endpoint running in SageMaker. The next step is to configure that same endpoint in LangChain, right? So if we want to, we can set some model parameters here, such as the number of tokens to generate, or the maximum number of tokens to generate, and top P and temperature, which in a nutshell control how creative you want the answer to be, how exotic you want the vocabulary to be. Okay, feel free to look up those parameters. We've met them before. Then we need to provide input and output transforms. And these are really important because they will literally adapt the model input and the model output for LangChain. Okay, so obviously JSON is going to be our input format, and we need to define the prompt format here, right? So we saw that thing on the model page. So the model wants to be prompted like that, right? And this is exactly what I've implemented here. Okay, so we'll have the prompt and those inst markup tags here, okay, and the parameters. So that's it for the input. For the output, we just decode the answer. The generated answer includes the instructions, which, you know, I found inconvenient for printing the result. So I'm just basically filtering everything that comes before that prompt close tag here. Okay, so we'll just see the generated answer. If you also want to see everything that came before, including the RAG chunks, etc., just return the full response instead of splitting here. Okay. All right, so now we have our pre-processing and post-processing functions. Okay, and we can simply define our SageMaker endpoint as a LangChain LLM. Okay, so endpoint name, model parameters, content handler, which we just created. And we need a SageMaker client because this will bring the AWS credentials, right? If you omit that, you're going to get some permission errors. So we just need to know that we're allowed to invoke that endpoint, and that's how you do it. Okay, so before we go into RAG, we could try and ask a basic question, right? We could run a zero-shot example providing no context. So here's my system prompt. As a helpful energy specialist, please answer the question, focusing on numerical data. Don't invent facts. If you can't provide a factual answer, say you don't know what the answer is. Okay? Pretty reasonable. So that's my prompt template, the system prompt, plus the actual query. Okay? So I define my LangChain my LLM chain, with the LLM and the prompt. Okay, and then I can ask a question. So my question is, we're in the energy domain, right? So what is the latest trend for solar investments in China? Okay, so that's my query. And if I run it, this is the answer that I get, right? According to a report by the International Energy Agency, China was the world's largest solar market in 2020. Okay, that's a few years ago. The report also states that China's solar market is expected to grow. However, the report doesn't provide specific information on the latest trend for solar investments in China. So, not a terrible answer, probably factually correct, because I'm guessing this document was in the training set. However, it's a little bit outdated, right? There's nothing beyond 2020. And the answer is actually quite honest about the fact that, yeah, it's giving us this information, but it's not super specific, and it's definitely not about the latest trend, okay? So again, not a horrible answer, but we can certainly do better, okay? So this is where RAG steps in. So let's look at how we can add fresh context to the mix, okay? So we have a few more objects here. If you already run the notebook, you will have embedded the database and saved it, so you can load it again so that you don't have to reprocess everything. But obviously, if this is the first time you run this, the shortcut will not be available. So let's continue here. So as mentioned, I'll start from those 3 PDF files coming from the International Energy Agency, right? So you can use anything else. The code below is generic, so if you use other PDF files, just go ahead. It'll run fine. So, as mentioned before, we're going to extract information from those files using Amazon Textract, which is a managed service. These are big documents. They're multi-page documents. And they need to be in S3, okay? So that's why I need an S3 bucket and prefix. I'm copying my 3 PDF files to that bucket and prefix, right? And we can see them here, okay? Again, you shouldn't need to change anything here, unless you want to change the prefix, obviously. So now I've got my 3 files, so I can easily build a list of S3 URIs, okay? So I've got the full path to those 3 PDF files in S3. Okay, simple enough. Okay, so now I'm gonna analyze those documents, meaning extract the information. So these are complex documents, lots of tables, lots of graphs, definitely not just text. And so that's why I'm using Textract, because I just want to extract everything, and hopefully I can use as much information as possible. So Textract is actually pretty simple, and it is integrated with LangChain. So that's good news. We're going to need 2 objects. We're going to need a Textract client from AWS, and we're going to need a splitter, as you can imagine, to split the extracted documents into chunks. So here I decided to have rather small chunks, 256 bytes, without overlap. Right, so no overlapping chunks, but again, feel free to experiment with different values. Okay, and then I'm simply looping over my 3 URIs, loading each document to text tract, receiving the extracted document. You can see how simple this is, really. Then splitting each document into those 256 byte chunks, okay, and then merging all the chunks. So you can see the first document was 137 pages, the second one was 181 pages, and the last one was 355 pages. So that's about, yeah, I would say 700 something pages, right? And we have a little less than, I guess, 10,000 chunks, okay? And this took 5 minutes. So I don't know, is that fast? Is that slow? I don't know. I didn't try to optimize. It's simple and it's really all I wanted, and certainly fast enough for my demo here, right? Okay, so now we have all those chunks, and again the chunks are just, you know, shorter bits of text extracting from those documents. So the next step is to embed those chunks and store them in our backend. Okay, so what embedding model are we using, right? That's a question I get a lot. So we have built a leaderboard, okay, for embedding models. You're probably familiar with our LLM leaderboard, but there's also one for embedding models, right? And this is based on the massive text embedding benchmark, which is available in 3 languages and different tasks. Okay, so if we look at this, and I'm interested in English here, obviously. So we see we have, you know, we have the best models here, lots of dimensions, but pretty large models, 1.3 gigs. So I actually went for this one, okay, so the smaller version, which is only 130 megabytes. So I guess just a bit bigger than maybe sentence transformers, which a lot of folks use out there. So it's got fewer dimensions, but the benchmarks are still very good, and I felt, you know, this should be fast enough and accurate enough for this demo. But feel free to experiment with bigger models. Obviously, the bigger the embedding model, the longer it takes to embed, and the more storage you're going to require, right? Because the embeddings are bigger. But anyway. So this is the leaderboard. It's a good place to start. So this is the model I'm using here, defining it as an embeddings model in LangChain. And then, well, simply creating a new face index, starting from all the chunks and embedding them with the embeddings model. And I love how simple this is. And if you look at the LangChain documentation, you will see there are many options for data stores, from, you know, very simple things to, you know, vector databases, etc., etc. Again, feel free to experiment, but here for this demo, I think the simplicity of face is just excellent, and it takes about 6 minutes to embed everything. So this is running. This notebook is running on AWS. It's a T3 instance, so you know, CPU instance, very small one, and again, I guess 6 minutes is fine. You would get obviously better performance if you run this on, I would say, bigger CPUs or maybe even GPU. But I wanted this demo to be economical. Okay. So 6 minutes later, we have our face index. We can save it. Okay, so now we have the shortcut. And now we are pretty much ready to query, right? So we'll configure our face index as the retriever, okay, so as the source of truth. I've decided to fetch 10 documents, right? They should fit in the context. Again, feel free to experiment with this. And now here's my template. Okay, so I started from the same prompt as before. As a helpful energy specialist, please answer the question. focusing on numerical data, blah, blah, blah. Okay, so the question is here. And obviously, I'm injecting the context into the prompt. Okay, so the 10 chunks that are retrieved through LangChain are going to be available there. And I guess I really pointed the model as this. Hey, this is useful context to expand your built-in knowledge. Probably there are better ways to phrase it, but I thought I would insist on, hey, please use this stuff. Okay. All right, so I'm using this template to build the actual prompt. Okay, so the context and the question will obviously be injected when we run the query. Okay, the two input variables. So now I can build the chain. Okay, so I'm using a retrieval QA chain type. Okay, using the LLM. I'm using the stuff policy, which is okay. Just grab 10 chunks and put them into the prompt. There are some additional ways to do this. You can try to refine. You can try map reduce if you have tons of data, and that won't fit into the context. But I like to start simple, and stuff is certainly the simplest way. The retriever, so the face index, and obviously my prompt. Okay. So now asking my question again, I get this answer, right? So now the model is pretty definitive about the latest trend. So it certainly found information in the index. It's giving us numbers for 2022, and I feel this is just a better answer than the previous one. Feels, I guess pointier, more, more documented with more numbers, etc., etc. Not too sure what that steps thing here. I'm not too sure what that steps thing means. So why don't we ask, right? So what does steps mean? And here we get a very good answer. The step scenario is a scenario that provides a sense of the prevailing direction of energy, system progression, blah, 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 blah. Okay, so steps means stated policy scenario. Okay, and here you can see I didn't provide any context in the question. Obviously steps could mean a million things, but in the context of the extracted information, right? This is energy related, obviously, and I get a very, very clear answer on what that is, right? So pretty cool stuff. Again, feel free to ask all kinds of questions. Feel free to try other PDF files. But as you can see, this is a really simple way to build this. Once you're done, please don't forget to delete the model and more importantly, the endpoint to avoid unnecessary charges. Okay. So there you go. This is really what I wanted to show you today, and I think it's pretty cool that we have everything in a single notebook, right? We have all the main elements. We have the embeddings, the embedding model. We have the LLM. We have document extraction, document embedding, document querying, and you can see this is a very very short notebook. There's really not so much happening here. And hopefully that's a good place to start your own experiments. Okay, again, all the links to everything, including the code, in the video description. And I guess I'll see you soon with more videos. If you have questions, please ask your questions. I'll try to answer as many as I can. And until next time, keep rocking. Hi everybody, this is Julian from Hugging Face. In a previous video, I showed you how to build a simple retrieval-augmented generation chatbot using open source libraries. In this video, we're going to scale things up a bit, and instead of using the Facebook Face library for embeddings, we're going to use Amazon OpenSearch Serverless. So a managed service that should help us scale our solution, and will work with a slightly bigger dataset instead of just indexing 3 PDF files like in the previous video. Okay, let's get to work. The high-level architecture is still the same. We have an ingestion process, and this time we'll ingest a Hugging Face dataset containing news articles. We'll use an embedding model will store embeddings into Amazon OpenSearch serverless and will query those embeddings, retrieve useful content, and put everything into a prompt and feed that to our LLM. And I will still use the Mistral 7B model hosted on SageMaker. Okay, so high-level architecture is the same, but I guess our search infrastructure now is much more scalable and managed and resilient, instead of just using Facebook face inside a notebook. Okay, so let's start with the OpenSearch cluster, and I'll have some news to share there. In the interest of time, I've already created the OpenSearch infrastructure. So good news, bad news. Good news is it is super simple to create a collection, which I have done here. It is really as simple as clicking on create collection, right? And so once you have a collection, all you have to do there is create an index. And OpenSearch now supports vector indexes, which is exactly what we want, right? We want to store those embeddings, so high dimension vectors, and query them. So if you click on this, you just give your index a name. You add a vector field. I would recommend that you use the default name for that field, which is vector_field. Because that's what LangChain seems to use by default. So if you use fancier names, you have to tell LangChain where to query. So vector_field is simple. And just leave everything default. And one thing you don't want to get wrong is the number of dimensions. Okay, so the actual size of that vector, and obviously this will depend on the embedding model that you use. Okay, so you need to check the number of dimensions for your embedding model. For me, it's 384, and that's the number you need to enter there. Okay, enter all that stuff, click on confirm. You will have your collection, you will have your vector index, and that stuff is ready in no time. Okay, so that's the good news. The bad news is, and if somebody on the OpenSearch team is listening, happy to provide more detailed feedback privately. I had a very hard time figuring out permissions and IAM for all of this. So I'll show you my end setup, the final setup that just works for me. I'm not claiming it's great. It's certainly not secure enough, and it's probably plain wrong. But in the end, this is the only thing that ended up working for me. And again, OpenSearch team, I think a little more documentation or maybe just an end-to-end example would be super valuable. This felt way too hard for me. So how do I solve this? So I am running my notebook, which we'll look at in a minute, on a SageMaker instance. Okay, so it's the managed EC2 instance. It needs to invoke OpenSearch APIs, so it needs IAM permissions for this, right? So the role, and it would be the same if you ran a plain EC2 instance, right? So the role attached to that instance needs to include this stuff, right? So I created an inline IAM policy that gives me full access to all the Amazon OpenSearch serverless AOSS APIs on all resources. Again, this is way too permissive for production, but I decided to take shortcut in a shortcut and just make it work. Okay, but you will need those APIs to be allowed on maybe on your Lambda function or on your EC2 instance, etc. Okay, so you'll need that. Textract is not needed this time. I have Textract here because in the previous video we used Textract from the notebook instance. Okay, so you definitely need to have this, but it is not enough, right? It is not enough, and you also need in OpenSearch action for the collection you created. You need to the collection you created. You need to allow your principal. So the role attached to the, in this case, the notebook instance running the code, you need to add that principal to that policy, right? By default, it has a policy for, it has the principal for my user, my console user, which I guess allows me to run the open search operation in the AWS console. But if I want to run stuff programmatically, I have to add the role here. And well, I guess, you know, I'm an idiot and maybe I forgot everything about IAM, but I couldn't find a good documentation on why and where and how to do this. So just started trying things and this ended up working. Okay. So, but again, I'm an idiot, as we know. So long story short, make sure the role of the AWS resource running the code includes the OpenSearch API permissions as a policy here, and make sure you enable that role as a principal for your OpenSearch collection, which in the end makes a lot of sense, but I wish I'd found a nice page or a nice example to walk me through it, because I'm an idiot and I'm lazy as well. Okay, enough IAM. So we have our OpenSearch cluster set up, okay, and now we can start working with it. So I will still be using LangChain. I will still be using Hugging Face. In fact, I'm using the same LLM and the same embedding model as before. I will still deploy my LLM to SageMaker. I will still run my embeddings as part of the ingestion process in LangChain. And of course, I will be using OpenSearch serverless instead of Facebook Face. Okay, maybe let me zoom in a tiny bit. Okay, so install the dependencies that we need here. Import a whole bunch of objects, right? We'll see them in action in a minute. No changes on the SageMaker side. I don't think I have any. Well, obviously I am not ingesting PDF files this time. I'll be ingesting text, okay, from a Hugging Face dataset. So I have a Hugging Face dataset loader, and I think that's about it. And I will query OpenSearch, so I need that object as well. And I need a couple of OpenSearch objects as well for authentication, right? Because we're not done with authentication. Anyway, okay, first step, same as before, deploy the LLM on a SageMaker endpoint, exact same code as in the previous video. So deploy Mistral 7B on G5 2XL instance using our nice Hugging Face LLM inference container, okay? And you don't have to write that code, just so you know. If you go to the Mistral model page on the Hugging Face Hub, we generate the code for you, okay? Just click on Deploy SageMaker in case you want to try another model. I deploy the model, but I don't wait for the model to be deployed because this takes a few minutes and I guess I can take care of other things. Okay, so that's why we have wait equal false. So this will return immediately. And of course, we'll have to check later on that the model is deployed before we actually start invoking it. Okay, but that's a good tip to keep going with our process while the model is deployed. Okay, just like in the previous video, we need to adapt the input and output for LangChain. So again, same as before. The input function just adds the Mistral prompt, okay? If you use a different model, you certainly will have to change the prompt format here. And the output, which just filters the instructions that are also included in the answer. So I will just show you the answer and not the prompt and not the chunks coming from the RAG system, okay? But same as before. Okay, we take that endpoint and make it a LangChain LLM that we can feed into a chain. No difference there. Okay, so now the LLM side of things is taken care of. That thing is deploying, it's configured, it'll be ready to go. So let's fetch some data. So again, previous video I showed you PDF files and I thought, well, I need to show you something else. So LangChain has a nice data loader for Hugging Face models, and I thought, why not? And this Reuters data set is pretty nice. I've used it before. And it includes, as you would imagine, news articles, and the article itself is in the text column. So why don't we load that stuff? And we see that we have about 20,000 news articles. Okay, so interesting data set. And this is one of them, right? And it's, it's a little bit long, and it's got some metadata as well that I won't be really using, but I'm sure you could. I guess the dates in particular would be quite interesting to manage in OpenSearch, but yeah, haven't done it this time. Okay, so I've loaded my 20,000 articles. I'm going to split them into smaller chunks. I'm still using the recursive splitter from LangChain with smaller chunks. Why not? Because the articles are rather short in a way, so I do want to have like tiny sentences, and I guess I want to be looking for precise facts. So I figured, hey, maybe I want to try smaller chunks. Okay, so split those. Takes a few seconds. I end up with 150k chunks. Okay, and well, here's the first one, I guess, which is pretty much the first sentence from the first article and metadata. Okay, so now my data has been loaded, it's been chunked. Next step would be, of course, to embed it. Okay, so we'll use the same embedding model, the BGE small v1.5. Please look at the leaderboard that we've built for embeddings on the MTEB embedding benchmark. I think at the time of recording, this is number 8, which is still better than the OpenAI embedding model. Somebody asked the question in the comments. So yeah, this is a good one, and it's pretty small and it's pretty fast. And feel free to try something bigger, although of course embedding time will go up. Okay, so remember I said when we create the OpenSearch collection, we need to know how many dimensions we have. So of course you can go and check out the model page, or you can retrieve that value from the model configuration, right? And again, this will be 384. This to LangChain as a Hugging Face embeddings model, and we're good to go. Okay, so LLM deploying, data ready, embedding model ready. So now it's almost time to embed and ingest. Of course, we still need to do a bit of security. We need to define the credentials for our indexing operation. Okay, so that's not too difficult. You need the name of your OpenSearch host, which you will find in the OpenSearch console. Okay, you should not, or I guess you must not include HTTP, HTTPS. You must not include port numbers, etc. Just the name. Okay, and of course I tried all those things and wasted my time on it. The name of the index that you created. Okay, so that's the vector index name. The region you're running in, and then just grab your credentials from Vodo 3 and create an AWS v4 signature using those credentials for that region and for that service, right? And this must be Amazon OpenSearch serverless, AOSS. Don't use ES, which would be Elasticsearch, and it's not going to work. Okay, if you don't know what an AWS v4 signature is, lucky you, just trust me that you need one. And basically it's how we sign HTTP queries, or HTTPS queries actually, going to AWS services. Okay, so now we're done, and we can start embedding and storing stuff. Okay, so we have 150k documents, or chunks I should say, to embed. So to make sure stuff was really happening, I decided to embed and index them 100 at a time. Okay, so that's what I'm doing here, breaking down my list of documents into sublists containing 100 docs. You don't have to do that. It's just that I wanted to make sure I saw some progress, and then I'm just taking 100 docs and using the LangChain OpenSearch object to ingest those 100 docs, and they will be embedded automatically and stored in my OpenSearch cluster using HTTPS and the signature, etc., etc. Okay, and of course the index name, right? So that's what it is. Not too complicated, but yeah, you need to get all those security details right. And if you have good DevOps engineer, they'll figure that stuff out, right? They'll make it safe and they'll lock down the configuration. But yeah, I actually spent more time on IAM and AWS v4 than on anything else, which is a bit frustrating. Anyway. Okay, so we store all those things. Okay, so it takes a little while because again, I'm doing this on this instance. It's a tiny instance, by the way. I'm running everything here on a T3 instance. So for sure, the embedding model running there is not running at full speed, and it's still running on CPU. So probably you wouldn't want to do this on either in a notebook or neither in the notebook nor on a tiny CPU instance. Okay, but so don't mind the time if you use a proper production server for this. It'll be much faster. Okay. So ingestion is complete. Let's take a quick look at the OpenSearch index. Okay, so all right, we have 150 something documents, which is close enough to what I had in my collection. Okay, we can see the index is 1.4 gigs. All right, well, looks fine to me. And I guess we have metrics. We have some metrics there showing us data rate, success rate, etc., etc. Okay, well, so everything's ready, it seems, and we can continue. Okay. Okay, so now we can start asking questions. We just need to set our OpenSearch collection as the retriever. We'll return 10 chunks. The prompt template, right? Pretty straightforward. Feel free to tweak. This time I'm asking the agent to cite the title of the articles it used. So let's see if this works. Okay, the prompt template, the retrieval chain. Okay, the LLM will use the stuff type, so just pack all the chunks together, our retriever, and the prompt. Okay, we just need to make sure the LLM has been deployed. So given the ingestion time, I'm pretty sure it was deployed. There's a simple way to do this. We just use a waiter. So just asking the SageMaker client to wait until this particular endpoint is up. Okay, and of course it is. Okay, and now we can ask questions. So let's try this. What are the worst storms in recent news? We just had a very bad storm in Western Europe, or in France at least, heading out to the UK. Good luck with that. And yeah, let's ask that. Okay, so we're going to embed that query with our embedding model and go look for relevant documents in our vector index, return them, add them to the prompt, and then let the LLM generate. Okay. And so this is what we get, and we get 2 Reuters articles. Okay, so we get the sources. That worked. This is pretty good. We could go and check those particular documents and maybe fact check that the answer is correct. So the Reuters dataset includes pretty old stuff, right? So it's pretty fun. I mean, you can ask questions about the USSR and so on. So it's good fun. It's good fun. You can explore history with this. Okay, well, this is really what I wanted to show you. I guess a nice upgrade to our previous attempt at retrieval augmented generation. Definitely, I like the open search managed service. I like the scalability. I didn't like the permission so much, but that's probably me. And now it's working fine, and I guess I'll continue exploring. Okay, so as usual, everything will be available. Just go and check out the video description, and yeah, let's see where we take this next. And until this happens, keep rocking.